This is a problem on nuclear binding energy. The question says, calculate the nuclear binding energy in joules and the binding energy per nucleon for the following isotope. Niobium, which has an atomic number of 41 and a mass number of 95. And it gives us the AMU of niobium, which is 94.90684 AMU. So we know we have the 41 as the atomic number, so we know that there are 41 protons in niobium. So write down 41, and we subtract 95 minus 41 to get the number of neutrons. So you subtract that in your calculator real quick, you get 54. We know that the mass of a proton, AMU, is 1.007825 AMU, and the mass of a neutron is 1.008665 AMU. You can calculate those real quick in your calculator, and you get 41.320825 AMU and 54.46791 AMU. Now we want to solve for delta M, which is a change in mass. To do this, we take the 94.90684 AMU that we were given in the beginning, and we subtract it by the addition of these two products. So we'll take 94.90684 AMU minus 95.788 735 AMU, and we are given, or we are left off with, an approximation of negative 0.88. So now we have our delta M. This value will be used in the equation delta E equals delta M times C squared. We're trying to solve for delta E. To do that, we have delta E equals negative 0.88, because that's your delta M, 0.88, and C squared is a constant that is already given to you, and that is 3.00 times 10 to the 8 meters per second squared, and this value is named. Plug that into your calculator real quick. Delta E, you're left with negative 7.92 E, or times 10 to the 16th. We are given this value for delta E, but we want to convert it into a unit of joules. And 1 joule is equal to 1 kilogram times meters squared per second squared. So this value, our units are AMU times meters squared over second squared. We want to multiply this by 1.0 grams over 6.022 times 10 to the 23. This is Avogadro's number, times 1 kilogram over 1,000 grams. Cancel all your units out. MU, grams, grams. And you are left with delta E is equal to 1.32 times 10 to the negative 10 kilograms times meters squared over seconds squared. Now I said in the beginning, 1 joule is equal to 1 kilogram times meter squared over second squared. So this value is 1.32 e to the negative 10 joules. That is the nuclear binding energy of the problem of the following isotope. But we also have to find the binding energy per nucleon. And to find that, all you have to do is divide the nuclear binding energy by the number of nucleons, which is 95. So you divide that by 95, and you are given 1.39 e to the negative 12 joules per nucleon. And that is your final answer.